In this video, we'll be talking about troubleshooting the grid by inspecting the aspect ratio of the grid cells and where and how to use the field error tool. So for the aspect ratio, remember to check it prior to solving. You can see the highest aspect ratio on the bottom of the project manager window when you have grid activated. So you can click G on the keyboard and that will activate the grid. You can also locate the highest aspect ratio by clicking on the grid summary icon as seen here. The highest aspect ratio will be listed on the top of this column here, and on the right it will tell you the two objects responsible for that large aspect ratio grid cell. If you click on zoom to, it will be highlighted in the drawing board. Now the aspect ratio of a grid cell is taking the largest dimension of the grid cell and dividing that by the smallest dimension of a grid cell. So a long, narrow, rectangular grid cell will have a high aspect ratio. The ideal case for a grid cell is to have unity as a maximum aspect ratio. Now that is not practical, as that would drive the number of grid cells to an unreasonable number. So a balance between the number of grid cells and a low aspect ratio has to be found, and that will be model specific. So for example, if you have a complex model which has long thin geometry in a large environment, that may have high aspect ratio cells, but it still could be solved. It also depends where that high aspect ratio is. If it is not in a critical area of your model and the solution converges, your gridding may be fine. And also keep in mind the localized grid transition ratios. Try and keep the number of grid cells merging onto one grid cell to be less than 10. Now let's talk about gridding deficiency. One tool to help you see where you may have a lack of grid is called the field error tool. This can be found under the solver control. You want to use this tool after you tried solving your model and have not reached convergence. Select the variable that has the highest residual error from your plot and run one more iteration for it to store those results. Now you can go to the visual editor and create a new plane plot and select field error for that plane plot. Here's a typical example where on the bottom left we have a high maximum for the field error. Note that the scale goes from a large positive error to a large negative error, and both can be indicative of a problem. So in this case, if we add more grid cells to the problematic area seen in the right picture, and then we rerun the calculation, we no longer see the large field error.